Go. All right, today we're doing mixture problems. This is a little bit of a review of what we've done. So these should come pretty easy to you. There's a couple tricks I need to tell you about. So we really need to get to the end of the PowerPoint. All right, so this is basically when you take something here and you take something here and you mix it. How do you get that mixture amount? Remember when we did notebooks and pens? Those mixture problems when we were doing notebooks and pens, when we were doing system of equations in chapter 8, it's basically the same kind of word problem. In fact, I remember when Miss Chi was teaching it, she said, why are they teaching this? Why aren't they teaching these problems in chapter 8? And I said, well, they kind of, it's a good time to place it in chapter 10. So, also systems of equations. So, Macy has $4,000 in stocks paying 12% interest and bonds paying 8% interest. Okay? Just like we did before. This is the amount. You should be writing while I'm writing. This is the units, and in this case, my units is in percents. Is equal to a product. What does it mean, a product? To multiply. We're multiplying across. And when we go this way, we add going up and down, and we get a mix. Okay? And we're basically going to make like a third row. We're not necessarily going to use all boxes, but we're going to make a third row. In this one, we don't necessarily. All right. My PowerPoint will call it something different, but again, it's the same thing. It's the same thing. Investment is the amount. The center part is the units, and the last part is the product. All right, so we know that in stocks, what percent interest are they paying? 12%. We convert that to a decimal, and that becomes 0 and 12 hundredths. Okay? And what percent are our bonds? 8%, and that would be 0 and 8 hundredths. Let's try and say our decimals correctly. All right, now the $4,000, is that stocks, bonds, or is that everything? It's everything. It's a mix. It looks like it's stocks, but if it were just stocks, it would stop here. It would stop right here. You with me? There would be a period right here. Because it keeps on going and paying 8%, bonds paying 8% interest, it's really the mixture of both. So since it's a mixture, our 4,000 is going to go on the bottom of both stocks and bonds. Because that's like where I'm starting, the amount that I'm starting with. Now, do we know how much we have in stocks? 4,000. No, 4,000 is what we have in stocks and bonds. What do we have in stocks alone? X. We don't know, right? So let me go back to, let's call that X, right? If I'm doing an addition problem, 3 plus a number equals 5. You guys with me? Yeah. Well, what is that number that's in that blank space? 2. We all know that's 2, right? Can I also write that as the total 5 minus the add-in 3? Here's the 5, and here's the 3. I'm just making up a problem. Is this another way that we can write that 2? So I can take, I don't know what that number is, but I can take the total 4,000 minus what I started with, the add-in to X. Do you understand that? Yeah. And that's what we're temporarily going to call the bonds. The total minus the add-in. Are you guys understanding how I got that? Yes. Okay, because we're going to do that the whole time today. A lot of the time. Okay, now we multiply across. I get 0 and 12 hundredths X. I'm going to get 0 and 8 hundredths times 4,000 minus X. And, oh, we have one more thing that we're missing. If she earns $432 in 1 year, how much was invested? If she earns $432 of total interest, right? That's what she's earning on the $4,000. That would go right down here. Does that make sense?
Yes.
Okay, so it's my equation. We're going to add going up and down. This is plus. This is equals. And so my equation is 0 and 12/100ths x plus 0 and 8/100ths times 4,000 minus x equals 432. Now, right away, I want to clear those decimals and not deal with it. So I'm going to multiply everything by 100. Now, in the first term, I get 12x. In the second term, what are we going to get? Plus 8 times 4,000 minus x equals $43,200 or whatever, 43,200. Okay, and now we're going to solve it. 8 times 4,000 is 32,123 minus 8x equals, I'm going to subtract that. I'm kind of out of space. Right? I'm going to subtract it. Oh boy, here, let's do. So I had 12x plus 32,000. Right? Oops. 8 times 4x. 4,000 minus x equals 432. 12x plus 32,000 minus 8x equals 43. Subtract that 32,000. What did you guys get?
2,800.
We get 12. No, we get 4x. Sorry. I'm so out of room here. 4x equals minus 11,200. And then I got 11,200 divided by 4, and it's 2,800. So x equals 2,800. Now, if they ask me for both, I can figure it out because 4,000 minus 2,800 would be 1,200. But the only answer I'm going to put in my answer column will be this $2,800 right here because all they're saying is how much was invested in stocks. I always go back to my word problems and make sure I'm answering what they want. Am I clear?
Yes.
Okay, yes, I'm understanding. No, I'm not. Thumb up, thumb down. Every thumb matters. Okay, does it feel pretty familiar?
Yeah.
Okay, it's a little bit different, but very familiar, so it should come very easy. I had some kids that told me they taught themselves. They're like, oh, it's really easy. We've already done this. All right. So here we are. I think we had similar problems, and this is where we are. This is where we are doing amount. You're doing what I'm doing. Times. This time, what are my units?
Peanuts.
No. No. That's amount. It's the money. This time it's money. Is equal to the product. Because it's dollars times a quantity, right? $5 it's 1, $10 it's 2, $15 3. You understand? Mm-hmm. And we are comparing peanuts and cashews. And this would be the mixture. Okay? All right, tell me how, do you guys want to pause it and just start trying to fill in this box?
Not by ourselves.
Okay, not by yourselves, okay. So, a 12-pound mixture of peanuts and cashews. Where would the 12 go?
In the mix of amount.
The first column, bottom triangle, so that will be a 12. That's 12 pounds, because this is amount, right? These are my pounds. This is my dollar amount. Now, sells for $6.50. Where would that $6.50 go? Next to the 12. $6.50. Okay, I've done that, I've done that. If peanuts sell for $3 per pound, where does the 3 go? In the middle column, next to peanuts. And cashews sell for $8 per pound. Good. Now, what are we calling our peanuts? Do we know how many peanuts?
No.
Okay, and so what would I call the middle term?
12 minus X.
The total minus minus X. The total, just like if I'm writing 3 plus a number equals 5. I know that that's a 2, but I could also call that 2 5 minus the addend. Do you understand? We don't know the number. If I don't know the first quantity and I don't know the second quantity, this is how I call it. Because I don't know either of them. I only know the total. If I assign a name to the total and I assign a name to the first one, then I could say it's the total minus the first one. Right? Okay, now we multiply across and see what we get. We're going to get 3x over here. And over here, I'm going to get 8 times 12 minus x. And then we will get 12 times 6.5 is 78. Okay. And I don't mind if you use a calculator tonight. In fact, if you have a calculator on you, you're welcome to pull it out and use it. All right. So now, what's my equation, Mike?
3x plus 8 times 12 minus x in parentheses equals 78.
Perfect. $96 minus 18. So divide by -5.
It's negative 18.
Huh?
Negative 18.
Oh, yeah. Divide by -5, and 5 goes into that 3 whole times. X equals 3, and I have a remainder of 3 over 5. I can convert that to 3.6. So what does that mean, 3 3/5 or 3.6? What? Yes.
Pounds of peanuts in the mix.
Right, so we're going to just do 3.6. We have the ability to find both if we need to, 12 minus 3.6, but we can stop there. 3.6, and remember, you need to write your units here, okay? It's not dollars, it's pounds that we found. Are you with me? Yes.
Would we be able to leave it at 3 and 3?
Yeah, that's fine. Fractions and decimals are equivalent. Unless you're learning how to do fractions, but they're pretty much equivalent, especially with word problems. All right, here's another kind of mixture problem, and they use it a lot with acids and solutions in science. Don't be afraid of it, it's exactly the same. So remember the top portion, I'll just label this whole thing. It's amount times what unit are we using here? Percents equals the product. And I'm comparing two different kinds. What is the first kind of solution? Let's call it a 10% solution. They're both acids. A 10% acid solution is mixed with a 60% solution. acid solution. 60% solution. Right? A 10% acid solution is mixed with a 60% acid solution to produce 120 liters of a solution that is 40% acid. What is the mix? What are we calling the mix?
10% of 60.
It's the 40%. That's the 40% mix. Because I'm getting it from the reading. A 10% acid solution is mixed with 60% acid to produce, that's the result, 120 of 40% acid. Does that make sense? Yes. So that's how I named them, what they're called. Okay? What decimal goes in here? Yep.
1/10.
0 and 1/10. What decimal goes in here?
0.
Everybody. 0 and 6/10. And what decimal goes in here?
0 and 4/10.
And 4/10. Good. Okay. Now, where does the 120 liters go? Where does that go? Bottom, first column. Right? 120. Because that is to produce. Do you see there is, this is, let me erase all this. This is where it's saying to produce tells me it's what they want to make. That's telling me it's the end. 120 of 40%. You guys with me? Yes or no?
Yes.
Okay, so, Valia, what am I calling the 10% solution? Do we know how much there is? No. So what do we call it? And what do we call the 60%?
120 minus X.
Perfect. Okay, multiply across. I get 0 and 1/10 X. I'm getting 0 and 6/10 times 120 minus X equals 0 and 4/10 times 120. So 0 and 1/10 X plus 0 and 6/10 times 120 minus X equals 0 and 4/10 times 120. I think I want to get rid of my decimals. I'm going to multiply by 10. X plus 6 times 120 minus X equals 4 times 120. X plus 720 minus 6X equals 4. Okay, 480. And now, subtract 720. Subtract 720. We have negative 5X. 720 minus 480 is negative 240. And we divide both sides by negative 5. Negative 5, what does it equal?
48.
X is equal to 48.
It's not because the two negatives are.
Yeah. So X equals 48. Could I have a negative solution? So it's 48 liters. So this is going to be liters. I guess you're having two sets of, you've got liters in one and the other units in the other. Does that make sense?
Yes.
So it doesn't matter if you want to call the middle and the other percent. So if that's 48, they want to know how much of each. What is the other one?
Oh, minus
20.
Is it 72?
70. Yeah, 72.
48 plus 72. So the thing to remember is that you always want to make sure and label. Like on the test, when we were doing the triangle question, you told me that a lot of people put the answers into a solution set when I asked for a base and a height. So when I want to know what the 10% solution is and the 60%, tell me there's 48 liters of this 10%. You understand? Mm-hmm. Be specific with it. Okay. We're doing okay. Okay, so now we're going again. Why don't you start it on your own? Because you're gonna there's a little hiccup here. So let's pause the recording. And so let's start it together. First of all, I'm calling the first top. What do I call it, Talia? Amount. Aaliyah times what?
Percent.
Equals.
Product.
Good. Okay, and then on the left side, how am I labeling it? Let's go with Atena.
I don't know. I think I know.
Well, what are the two quantities I'm comparing?
2%.
The 2%, 20% of what?
Of the solution.
So, what kind of solution?
Salt.
Okay, so the salt. And what am I mixing with it? What? Water. We're mixing water. And we want, what do we want? 8% salt. So this is like it's like chemistry. You're taking, and I know you did this when you were like little kids. I did it with mud and water and made all kinds of solutions. And then I washed the dishes in it and told my mom that this was the best way to clean the dishes. Okay? But you're like mixing things and you're watering one thing down. So that's what we're doing. Something that's 20% salt water, and we're adding water to it so it's less salty, right? When you're cooking, you do the same thing. I make my mashed potatoes. I put too much salt. I better throw some more milk in there, some more potatoes. Get rid of the salt taste, right? When I oversalt it. Okay, so now, Thalia, where am I going to... Mitch holds a beaker that contains 40 liters of a solution that's 20% salt. Where does the 20% go?
In the percent.
Huh?
Yeah, in the percent.
Good. First one, second, or third?
Second one. Oh, the first.
Good. And I'm going to write down 0 and...
2 tenths.
Good. And then let's say, where do you think that 40 liters goes? What is that?
Product.
Does it go in
Shh,
salt?
Thalia.
I thought it went in the amount.
It does. Where? Where?
The last.
Is which one is that 40 liters? Read it. 40 liters of?
20% salt.
20%.
So where does it go?
In the first.
Top, bottom, or middle?
Top one.
Top one. That's a 40. This is going to be a little different. Okay, this time they gave me that. Not the total. They gave me the first quantity. Do we know the second quantity? No, so let's call it X. So now, if I know the first quantity and we're giving the second quantity an X, what do we call the total? 40 plus X. Because quantity 1 and quantity 2 equal a total. When you add the first and you put the other in, it will make it's adding it. Does that make sense? Okay. Yeah.
How come the second box is in the 40%? Like the other ones?
Because this time they didn't give me the total. They gave me the first quantity. So I'm naming my second quantity. I'm not naming my total. Because then I would have two unknowns. Right? The first, I'll go back to the other ones. This time they gave me this. So when they give me the first one, I name my unknown X. And remember, isn't this plus this equals this? Does that make sense? Yes. So it's 40 plus X. Okay, now, here's where it gets even trickier. What percent of salt is water? Getting me thirsty right now.
0.8.
How about 0? How about 0? In water, does it taste salty? No. It's 0%. What is the 8%? Shh. So I'm mixing really salty with water to make it less salty. 8%. I start out with this really salty soup, 20%. Then I take water and I add it, so now there's only 8% salt. Does that make sense? Okay? And the bottom one is going to be 0 and 8 tenths. Are you guys with me?
Yeah.
Now, multiply across.
Wouldn't that be 80 though? 80%?
No, it's 8%. Oh, wait, yeah, you're right. Sorry, I'm wrong. That should have been 0 8/100. You're right, I'm wrong. Otherwise, it would have been 80%, right? Okay, multiply across. 40 times 2/10. It's 8, right? It's 8. And then we have 0. 8 plus 0 equals 0.08 times 40 plus x. So it's 8. I'm going to erase here. Put it all in regular writing. My equation is 8 plus 0. And now I'm probably going to clear out that decimal because I can't stand them. Multiply by 100. And I get 800 equals 8 times x plus 40. 8x plus 320 equals 800. Subtract 320. And we get 480 equals 8x divided by 8. And x equals 60, right? So this would be 60 liters of water mixed with 40 liters makes 100 liters. And so the question is, how much water must be added? 60 liters. Okay, do you understand what unknowns were given here?
Yes.
Okay. So what was tricky here is really, number one, the water is 0% when you're mixing with salt. You have to use, it's implied, right? And also this time they gave us this. And when they give us this, it's going to be addition down here. Do you guys understand that? It depends on what two you can create. Okay, as opposed to before, Mike, you were asking? You were asking, this time I was given the total. I named the x. You with me? Yeah. So then the only way I can get this middle part is to do the total minus what I don't have, total minus the beginning.
So if you get the
first or the second, then we name the other one x, and then we add it up and down. Okay? All right. So the next one is really the last kind of tricky one. And it's not that tricky. It's the same. It's just something is implied. So now we're doing paint. This is very common of painters. In fact, I hear my cousin complaining about it all the time. So I've got the quantity of paint times the percent of thinner, or percent, equals the product. Now, the two things that I'm comparing, it says a painter has 50 gallons of paint. 50 gallons of paint. Oh, dear. Okay, so a painter has 50 gallons of paint. That's 5% thinner. That's good paint. His mixture needs to be about 20% thinner. Why? Because it will be much cheaper for me to paint the house. That's why my cousin complains about this certain painter, because he adds too much thinner, you know, and so it's not a thick coat, and that's the way painters save money, right? And then they make more money. How much paint thinner should be added to the mix? So we want the mixture to be 20%. The current, what are we mixing? The first one is what?
Paint.
What kind of paint? It's a 5%, right? It's a 5% thinner in the paint, which is mostly paint. And what am I mixing it with? I'm not mixing with his mixture needs to be. I'm mixing it with just plain thinner.
Why is she mixing with paint?
I'm mixing the paint thinner in with the paint. Shh. And I want it to be 20% thinner.
What is this
Shh. The original paint has 5% paint thinner in it. I'm mixing it with pure paint thinner to water down the paint so I can have more quantity, because paint thinner is cheaper than paint. So then so I'm mixing my 5% gallon or whatever, 50 gallons with some paint thinner so that it's 20% paint thinner and the rest paint. It's going to increase my 50 gallons by 20%. Does that make sense? So, paint. What are we given?
50.
Where does 50 go?
In paint thinner.
In the
In
5.
paint, 5%.
Good. And that's going to be 0 and 5/10.
Yes.
And then,
Wait, 0.05.
yeah, 0.05. That's good. 0 and 5/100. Sorry, not 5/10. I put 50%, not 5%. All right? Now, do we know how much thinner?
No.
So we call it, and what would the total be, Mike? Mike, what is the total going to be? No, right here.
50 plus X.
Good. 50 plus X. Okay, and what do we want the end percent to be?
20.
Okay, 2/10. Now, thinner, here's the trick. What percent is the thinner? 100. 100%, which is 1. 100% is 1.0, right? So we multiply across. Does that make sense?
Yeah.
So some things are implied. Like when they're using pure thinner, it's 100%. When they're using water, it's 0% salt. Does that make sense? And then we're going to multiply it across and then finish. Okay, my equation's 2 and 5/10 times X
Hey, it's HQ time.
equals 2/10 times the quantity of X plus 50. Okay, questions? Now, tonight, when they start talking about milk, 1%, 2%, you've seen that on milk cartons? Yes. You never gone to the store. He's going, no, I haven't seen that. 1% milk, 2% whole milk, and then they have skim milk. Does anybody know what skim milk is? What is that? He said gross milk. It looks like water milk, right? And that's because skim milk is non-fat. There's no fat. What would that percent be?
0.
0% butterfat. That's right. So when you get to the butterfat, remember skim milk means 0 butterfat. Got it? Question. Recording, you two. Okay, yes.
Why wasn't it like in the last question, it was 0% for the water, so why was it 1 in this one?
Because the other one is I'm adding 20%. I'm going to try and weaken the salt with water. How much salt is in the water? 0.
And this is trying to
This I'm taking paint with 5% and I'm adding more paint thinner. 100%. I want to water down the paint, make it less paint and more thinner. The other one was making it less salt, more water. Going the other direction.
Okay, so is it?
Yes.
Why didn't you get rid of the decimal?
Just because the PowerPoint did it. I would do it. If I was doing it, I would get rid of them immediately. Right? And go multiply by 10. And I get 25 plus 10x equals 2 times x plus 50. 25 plus 10x equals 2x plus 100. Minus 2x minus 25 minus 2x minus 25. We get 8x equals 75. Divide by 8, divide by 8. X, did you guys get this?
Yeah.
75 divided by 8 is 9.375. That means I need 9.375 gallons of paint thinner to get a 20% solution. I mean, I need to increase it so I'm not spending as much money. All right, that is the lesson for today.
Oh.